So what I'm noticing about this complex fraction is that I have the same denominators here and here, here and here, and that's going to make it a really nice candidate to use our second method for simplifying. So I'm going to multiply by the least common denominator being x plus 1 times x minus 1. I got that by considering, what does this denominator have that this one needs? This has an x minus 1, this does not, so I would multiply by x minus 1 on this fraction, on the top and bottom. And then what does this denominator have that this one needs? This has an x plus 1, this does not, and so that's where I'm getting my least common denominator from. Same deal in the bottom. Remember, we need to kind of, when doing these problems, peer into our crystal ball, what's going to reduce, what's going to remain. So the x plus 1s here and here will reduce because one's on top, one's on bottom, and the x minus 1s will remain. So x minus 1 times x minus 1 equals, there it is there, x minus 1 times x minus 1. Multiply to here. First of all, take note of the sign is a minus. What's going to reduce? What's going to remain? The x minus 1 in the denominator will reduce with the x minus 1 in the numerator, and the x plus 1s will remain. Okay, I'm going to come back to deal with my kind of large denominator. After I'm done, let's expand the top. Take away x plus 1. Be very careful with the minus. What this expands into, that minus is going to be distributed. And so now we'll distribute the minus to everything. I could go ahead and add these if I wanted to. Let's go ahead and combine our like terms. That's going to be minus 2x from here and here. Take away x again. Is take away 2x's. Plus 1. We'll have minus x squared. I know 1x and 1x is a 2x, so when I distribute that negative, I'll have minus 2x. Then way over here, I'm going to have minus 1. And so then I'm seeing x squared and x squared sum to 0. Then we have negative 2x minus 2x's is take away 4x minus 4x. And we have 1, take away 1, that sums to 0. It's a really long fraction bar for that minus 4x. Okay, well, let's do the same in the denominator now. Peer into your crystal ball. What's going to reduce? What's going to remain? The x plus 1 in the denominator and the numerator will reduce. The x minus 1 and the x minus 1 will remain. Whoops, why am I writing it down there? Let me erase that. X minus 1, x minus 1. Take note of the sign, plus. Distribute to here. What's going to reduce? What's going to remain? The x minus 1 in the denominator and the numerator will reduce. You'll have an x plus 1 and an x plus 1 remain. Expand these. You'll notice that this and this are exactly the same, so you'll get the same expansion. X squared minus 2x plus 1 plus this and this were exactly the same as well, so you'll get the same expansion. X squared plus the 1x plus the 1x is plus 2x plus 1. You can distribute a plus if you want. It's not going to change anything. So you'll have the x squared, take away 2x plus 1 plus x squared plus 2x plus 1. X squared and x squared make 2x squared. Negative 2x plus 2x sum to 0. And then you have a 1 plus a 1 is a plus 2. So at this point, is this not going to erase? Why won't that erase? I don't know. Okay, that's all right. At this point, what I'm noticing is that I have a common factor of 2 here. And so I'll factor that 2 from this expression. 2 times x squared plus 1. And I see a factor of 4 and a factor of 2 on the bottom. That will reduce to 2 and a 1. So that's negative 2x over x squared plus 1. You want to consider, does this expression factor? This is a perfect square, this is a perfect square, but of course it's not a difference, it's a sum, so this does not factor, and we're done.